All right, we're going to get to working with some logarithms and looking at some of their properties here. So we're first where we have a logarithmic function where we've got b is some number, real number that's not equal to 1. M and n are also positive real numbers. And if we have this, it turns out what we can do is we can actually separate this into two logarithms like this: the log of base b of m plus the log of base b of n, just like that. All right, and so it's a pretty nice little trick. I won't go through the derivation, but if you think about something like I don't know, 2 to the 12th, that can be 2 to the 3 times 4, which would be 2 to the 3, or 2 to the 3. I'm doing that the wrong way. Hold on. 2 to the 6, let's say, that's going to be 2 to the 2 plus 4, which we can say is 2 squared plus 2 to the 4th, like that. So essentially, whenever we're messing with these, because these we're messing with exponents, and so the multiplication of them turns into the addition of them, and we get something like that. Like if you have x squared times x to the 3rd, that's x to the 2 plus 3 kind of a thing. So our 2 plus 3 comes from our times there. All right, I think I wrote it wrong the time before that. But anyway, let's take a look at this and see how we can use here. So we've got log of base 4 of 7 times 5. We can actually rewrite that as log of base 4 of 7 plus log base 4 of 5. All right, and then we can't really reduce any of these anymore. We can't actually determine what the logarithm is without a calculator. So we move on. We look at number 2. Here we can say log base 3 of 9 plus log base 3 of y. We can separate that out. Now for this one over here, log base 3 of 9, we can actually go ahead and reduce that one, and it becomes, 3 to the what power equals 9, and that is 3 squared. So that becomes a 2 log base 3 of y, right? And so how I solved this log base 3, what I basically said was, what if I had log base 3 of 9 equals x, like that, what would it be? Well, it would be 9 equals 3 to the x. And so I'm just trying to figure out what would that exponent be, and it would be 3 squared. So that 2 is what went right there. Okay, so I'm going to go ahead and pause right there, and I'm going to give you a chance to try those next two. All right, you can see the answers to these ones here worked out for it. And so we'll go ahead on this next one. The next thing is the quotient rule. This is where we have the log of something that's of two things that are being divided, that there's a quotient in. For this one, we actually end up with log of base b of m, and then it's minus log of base b of n. In fact, this one actually is a rule that we can come up with on just using the product rule we just did, and then the next one that we're about to do after this. So, I mean, it's good to remember it, it's good to use, but if you're ever in a pinch, you can always kind of just fall back really on just the product rule, and I'll show you that in a little bit. So let's take a look at using this. If I look at number 7, I've got log base 7 of 19 over x. I can write that as log base 7 of 19, and then do a minus log base 7 of x. And so that right there is all I can do. I can't reduce any more of those logs. I can't evaluate any of the other logarithms there without a calculator. And so that's pretty much it. Okay. And then I'll try number 8 for you here real quick as well. We have log base 5 of 25 over y. So that can become log base 5 of 25 minus log base 5 of y. So there we go, that's done. Except my log base 5 of 25 can be reduced because 5 squared equals 25. That means that 2 is what my logarithm is. All right, so that's going to give me this answer up here. Log base 5 of 25 is 2. And then we have the minus log base 5 of y, just like that. Okay, so go ahead and try numbers 9 and 10, and I'll give you a few minutes to try them. All right, here are all the answers for that one for anybody watching the video. And we've got, of course, I did the ones at the bottom too, where the bases had to match and we could just do them in reverse order. So if you need to pause it, there you go. Over here, we've got one more rule. It's the power rule, log base b of m to the p power. So if there's an exponent inside our logarithm, then we can actually make this p times log base b of m. And this is actually just a kind of like an expansion of the product rule that we had at the beginning. If we look at the product rule, we would say something like, let's say we had log base 3 of 2 to the, or not, let's do this log base 5 of 2 to the third. How about that? Well, we can make this the log base 5 of 2 times 2 times 2 because there's 3 of them, like that. And then if I use my product rule from the first, this would become log base 5 of 2 plus log base 5 of 2 plus log base 5 of 2. And so I have just 3 of the same thing being added together. Kind of like if I had x plus x plus x, it would just be 3x. This just becomes 3 times log base 5 of 2. And so you can see the ultimate result that ended up occurring is we ended up taking this 3 in the exponent and putting it out front, just like we do down here where this p ends up going out in front, right? We're taking that p and we're moving it out in front for this rule. All right, now be careful when you're doing this because everything inside the logarithm has to be raised to that power in order to do it. So you would not want to do something like log base b of n times m to the p. You would not pull that p out in front. Don't do that because n isn't raised to the p power. You'd have to have n raised to the p power as well. They all have to be raised to that power in order for you to move it out front like that. So be careful. Don't do it there in that situation. All right, let's take a look at number 13 here just to see how this works. We've got, oh, actually, I want to show you one more thing. How can we do the quotient rule with this? I'll squeeze this in right here. So if I have log base 5 of 3 over 2, this can be log base 5 of 3 times 2 to the negative 1. Where that 2 is the negative 1, it's 1 over 2, it becomes 2 to the negative 1. And then I can apply that product rule, log base 5 of 3 plus log base 5 of 2 to the negative 1. And then you can see as soon as I then use my power rule, I'm going to bring that negative 1 out front and it'll change that to a minus. And so it would end up being the log base 5 of 3 minus the log base 5 of 2. So really you really just need this rule and the very first one. But to be honest with you, I don't usually go about doing them this way. It's kind of long. But if you're ever in a pinch and you forget, as long as you at least remember the first one, you should be able to come up with these other two. Okay, but still, I recommend just remembering all 3 and using them. So here we've got log base 5 of 2 to the 7. That means we're just going to take that 2, bring it out front, and get 2 times the log base 5 of 7. All right, so just that easy, just like that. And then I'll do one more for you here. We have log base b of x to the 5th. We're going to take that 5, bring it out in front, and it'll be log base b of x, just like that. All right, so go ahead and try the next two there and see if you can get those done, and I'll pause this for a minute while you work on them. All right, here are those problems done. I even did an extra little one over here, which again, I don't recommend that it be done that way, but it works. It works out. We could come up with the answer was 3, and even if we went around using all our log rules properly, we eventually got to 3, even though we use them in a way we probably wouldn't have normally used them because it's long and drawn out. And then down here, we just ended up hooking them together. All right, so for the next part, it's about putting them together. And so we're going to use all our rules and try and take these apart. So I'm going to do 19 and 20 here real quick. So this is log base b of x times y to the 4th. Now I cannot bring this 4 out in front because it's not there on the x, right? It's not there on the x. It has to be on everything in there. So I can't do that. So the first thing I can do is actually just separate these. Log base b of y to the 4th. That's the very first thing I can do, is use the product rule. After that, now in this second logarithm, I can actually take this 4 and bring it out front because everything inside the logarithm has it. So this becomes log base b of x plus 4 times the log base b of y. Okay? And so there it is. We fully expanded out. We can't do any more than that. Okay, let's take a look at this next one, number 20 here. So again, I have something with a square root, so I can rewrite this as log base b of x squared times y to the 1/2. Now they both have exponents, but I can't bring either one of them out front because their exponents don't match. So I can use the product rule first, and I can separate this into log base b of x squared plus log base b of y to the 1/2. 1/2. All right, just like that. And then I can do my power rule where I can bring the exponents out front. 2 times log base b of x plus 1/2 log base of y, just like that. Okay, and so there's that. This is just taking them apart and expanding them. You just have to figure out what order you can do them in and go through and do them. One last thing real quick, just on the next page, it's about doing it again, but it's about condensing them this time. So this time you want to bring them together. So I'm going to do these 2 examples too here while I'm doing this, and then you can work on them. So here, I can't combine these together. They both have the same base, but their coefficient out front is different. This has a 2, this has a 1. So the very first thing I want to do is make sure that not only do their bases match, but the coefficients out front are the same. So I'm going to take that 2 and move it up there to an exponent. This will become log base b of x squared minus log base b of y. And now I can go ahead and use the quotient rule to combine the 2 logarithms together, and I'll get log base b of x squared over y. So doing the same sort of thing, just working totally in reverse. All right, I'm gonna go ahead and do one more of them here. Log base 10, so just a log of x plus 3 times the log of y. So again, I can't combine them together because those coefficients out front are different. So I need to move that up front. So I get log of x plus log of y cubed. And now I can use the product rule because it's the 2 logs of the same base being added together. And this will become log of x times y cubed, just like that. All right. So I'm going to go ahead and pause it, see if there's any questions. But otherwise, start working on these ones here and on the next page and see how we do with the rest of class.